Hello everyone. This video is also another example of Newton's third law, and it's also a very famous problem. It's about the weight. Okay, weight. Sorry, weight in the elevator. Okay, suppose we are people called John, a person called John. He's sitting on a scale, and it's in the elevator, and what is what's the reading on the scale will be. Okay, it's a famous question, and we use this also problem to want to more familiar with the action and reaction pairs in from discussing Newton's third law. Okay, so like I said, if the whole elevator has different acceleration, the reading on the scale will change. So how to analyze this problem? So for this problem, we focus on the person called John, and we treat John as a point. And there's a force on from Earth pulling John downward. As its weight. Like I said, the weight is a force, right? And at the same time, the John feel a normal force from the scale. The normal force from scale. So I would say this normal force, I give it a name. It's from scale to John. Okay, scale to John. Okay, and so how do the scale show the reading? How the scale show the reading? Because the scale and feel equal and opposite force from John. It's called here. I think it's here. This force is from John to scale. Okay, because the scale has a normal force to John. So at the same time, John also has a force to scale. Okay, so this is equal and opposite. This is action and reaction pair. Action and reaction pair. Reaction pair. On Newton's third law. And it is this force to give reading. Give the scale reading. So and the force is equal amount. The magnitude of this force is equal to the normal force, equal and opposite direction, equal magnitude but with opposite direction. Okay, so let's apply the Newton's law. Newton's law says F equals to ma. So what's the force acting on John? So yeah, like I said, we need to focus on, we now do the analysis on John only. JOHN on John only. So what's force acting on John? I think it's right now if upward is positive and down is negative. So positive, we have a normal force, okay, minus the weight, it's mg, as mj times g, and equal to the mass of mj and its acceleration. So it's pretty much the equation we have to use, and we need to find out the find out the m. M is equal to mj and g plus a. Okay, that's pretty much about it. So, okay, answer the question. And you say, why don't I consider this? Why don't I consider FJS in this equation of motion? Because like I said, we are focusing on John. So we are interested in the force acting on John. The FJS is acting on the scale, not on John. Okay, since we want to know, although we want to know this value, but when I do the analysis, this force is not acting on John. So when we focus on John, I just ignore it. And how could we find the FJS? Just like say, it's equal amount of n. So if we find the n, we find the FJS. So So the first question is very simple. Okay, A equals 0, so that's mj times g. So it's 60 kilometer times acceleration. I think you can calculate on that. And it's Newton. The unit's Newton. And B, if its acceleration is upward, the the reading is will be 9.8 plus 2. And the unit is Newton. Okay, unit is Newton. So what is FC? The normal force 916 times 9.8 is the acceleration ratio now is 2 meters seconds per second squared, but it's downward, so it's minus 2. So when the whole elevator goes up, the reading goes up, and when the elevator goes down with the acceleration, the reading goes down. I think you feel it when you ride when you take the elevator. I think you feel that, right? Right. This really makes sense. Okay. So what if and let me tell you a very interesting situation. If A is equal to minus 9.8, or just like G, just minus G, what is happen? Your reading will become is G minus G will become 0. Okay. Okay, that's called weightlessness, right? Am I right? Which one? Yeah, weightlessness. It's when the elevator doing the negative 9.8 acceleration downward, that means the elevator is doing the free falling. So when the elevator doing free falling, you are in there. The reading is goes to 0, but that's not a good thing. That means you are doing the free falling motion with the elevator. Okay, so it's called weightlessness. Okay, so it's a famous problem. So I hope you can understand this and give you more sense about action and reaction force and how should we treat these action reaction pairs during the force analysis. Okay, and I'll stop reading the video here. So thank you for watching. See you next time. Bye bye.